how to use the principle of reference angles to calculate any angle without using the calculator. Please, are there any questions there? Please, are there any questions there? Reference angles. Are there any questions there? Reference angles. Are there any questions there, please? Please, I'm waiting for you. Reference angles. Please, I'm waiting for you. Hello? Can you hear me? Can you hear me?
We can hear you, sir.
Okay, so I'm asking that is reference angles fully understood? Yes, is it fully understood? Yes or no? Is it just a yes or no answer?
No, sir.
No, okay, good. Okay, now we are going to look at some questions on reference angle. Most of the time, it's better we do the ones that have not been done so that it will be faster. So, can we look at activity 8,9? 8.9. It will be on page 22. Activity 8.9 on page 22 of the book. Are we all there?
Yes, sir.
Are we there?
Yes, sir.
Okay, good. So, if you can look at the first one, we have been given cos pi over 6. We have been given cos pi over 6. Now, cos pi over 6 is positive. Before we even continue, last week I told you that reference angles only gives them the signs, only tells us the direction of where your angle is going, whether it will be going clockwise or anti-clockwise. So here we are having a positive pi over 6. That's what I mean. So it's enough that it means that your so it says cos, we should evaluate cos pi over 6. Always, it's important to find the reference angle. It's very important because the reference angles always gives us a special angle. Now, cos pi over 6 is a special angle because we know cos pi over 6 is the same as 30 degrees, which is a special angle. But still, you must indicate your reference angle. So if we look at the cast, where will be cos pi, and please, you always draw your cast. It's very important that you always have to get your cast. 3 pi over 4, and here is 2 pi. Sorry, here is 2 pi. So cos pi over 6, it will be between, it is the same as 30 degrees. Please, we must learn to work in radians. But if the question is in radians and you are not so sure where it will be, simply quickly convert it to degrees by multiplying by 180 over pi. Then you quickly convert to degrees so that you know exactly where your which quadrant your angle is going to be, because the quadrant where your angle is going to be is extremely important. Okay, good. So here is positive, so it's going to go what do you call it, anti-clockwise. So pi over 6 will be somewhere here. You see that? Pi over 6 will be somewhere here. And your closest angle to pi over 6 is 0 degrees. So the ref angle is going to be pi over 6 minus 0, which will give out the same pi over 6. So even though we know that pi over 6 is a special angle, still you must indicate how you are going to get your reference angle. So straight away we know that cos pi of the reference angle is pi over 6. So that means that your cos pi over 6, you know that is the same as cos 30. If you want to punch cos pi over 6 using your calculator, you must then have to change your calculator from degrees to radians. Then your answer will obviously be root 3 over 2. Please, any questions with the first one? Can we go on?
Yes, sir.
Okay, good. So in the absence of no questions, let's go on to the second one. The second one, in that same question, we have tan negative pi over 4. And please, you must pay attention here. Good. See that here, the angle is negative. Can you see that? Can we all see that?
Yes, sir.
Okay, good. So we have pi over 2. Then we have pi 3 pi over 2 and 2 pi. So here, because of the negative, this time you're going to measure in the clockwise direction. Have you seen? So here, your pi over 4 is going to be here. As I have told you, the negative only tells us the direction. You understand me? So you don't bring the negative. Have you seen that? The negative only tells us whether the angle is going clockwise or anti-clockwise. And here, because of the negative, it's going to go clockwise. If it's positive, anti-clockwise. Please, is this point clear?
Yes, sir.
Okay. So still our nearest how do you call it? X-intercept to pi to this angle, pi over 4 is 0. So our ref angle is going to be pi over 4 minus 0, which will give us pi over 4. We all know that pi over 4 is a special angle, and pi over 4 is the same as 45 degrees. So tan negative pi over 4. Please let us remember the cast. CAST. Here we saw that the angle is in the 4th quadrant. And in the 4th quadrant, tan is negative. It's only cos that is positive. So that will make our answer -1. Is that because tan, the reference angle is pi over 4. Ne? Tan pi over 4 is 1. But because the when we drew the angle on the cast, it put us in the 4th quadrant. In the 4th quadrant, tan is negative. That's why we're having -1. It's very important for you to recognize this one. Please, any questions there?
Sir, please explain again. I didn't understand.
Okay. What exactly didn't you understand? If you can tell me clearly.
Explaining why tan pi over 4 is -1.
It's negative. Okay. We know that. Okay, just punch, and we know that the angle, the reference angle is tan pi over is pi over 4. Ne? When you punch tan pi over 4, what do you get? When you punch tan pi over 4, what do you get?
0,0137.
Because we are working, you see, if because it is in radians, you must change on the calculator, change from deg to rad. You understand me? If you are working in radians, it must be in rad. You understand me?
Okay. I
So
think
try it
so.
again and let's see the answer. Have you found it?
Yes, sir, I got it. It's 1.
It's 1. Have you seen that? It's
Yes,
1.
thank you.
But then if you put 1, you are going to be wrong. Do you know why? Because the angle is in the 4th quadrant. Remember, you remember this thing where I'm circling cast. Have you seen that? Cast shows that in the 1st quadrant everything is positive, but in the 2nd quadrant only sign is positive. The rest is negative. In the 3rd quadrant, tan is positive. The rest is negative. And in the 4th quadrant, cos is positive. The rest is negative. And here, when we drew our angle, have you seen? We saw that it's going to be in the 4th what? In the 4th quadrant. You understand me? And in the 4th quadrant, tan is what? Negative. So you cannot say that tan pi over 4 is 1. It's going to be -1.
Okay, thank you, sir. I understand.
You understand? Okay, good. Please, any questions again? Please, any questions again?
No questions, sir.
Okay, good. Then let's go to the next one. Our next one, we have sine 210. Sine 210. Again, please. You see that here they have switched from degrees to radians. So if you forget to change the mode on the calculator, you are going to be punching wrong answers. You understand me? Have you seen that? So always watch that mode, whether it is in radians or it is in degrees. You understand me? If it is in radians, make sure that on top there is rad. If it is in degrees, make sure that on top there it is degrees. Okay, good. So here we are working in degrees. Ne? So let's find here will be 0, 90, 180, 270, and here will be 360 because we are working in degrees now. So 90, 180, 210 is going to be here. Do we all agree?
Yes, sir.
Okay, 210 will be here. So our reference angle is going to be 210. The nearest x-axis is 180 minus 180, which is going to give us what? 30. Can you see that? So our reference angle is 30. So sine 210. We are not going to find sine 210, but we are going to find sine 30 because our reference is 30. Now, sine 30 is going to give us, if you can find sine 30 on the calculator, you are going to get root 3 over 2. But again, if we draw our cast, we find out that 210 is in the third quadrant. Have you seen that? And in the third quadrant, sine is negative. Have you seen that? So it should be negative root 3 over 2. No, sine 30, no. Sine 30 is half. So it's going to be negative half. Because in the third quadrant, sine is negative. Please, any questions there?
No questions, sir.
No questions. Okay, no. Okay, your hand is up. Your hand is up.
I've been struggling when having a negative number. Let's say, for instance, if it's sine negative 210. Yeah, I've been struggling with such.
Okay, good. So let's look at that one. Let's look at that one. Let's look at that one. Sine negative 210. Good. So let us draw our cast. You have 0, 90, 180, 270, and 360. So I don't know whether you joined us at the beginning. Because of the negative here, this time we are going to go we are going to go clockwise like this. Have you seen that? So from here to here is 90. Have you seen that? From here to here is what? 180. That means that the negative, your angle will be here. Negative 210 will be here. But as I say, you don't bring the negative. It only tells us the direction. At this point, is there any questions, please?
No questions, sir.
Okay, so your ref angle, the nearest x-axis is 180. So it's going to be 210 minus 180, which will give us 30. Now we know that sine 30 is going to be what? It's going to be half. But sine 2 in the this time, you see that because we went in the other time, this time it has come into the second quadrant. And in the second, sine is what? Positive. So that means that sine negative 210 will give us positive half. Have you seen that? Because Sine negative 210 moved us to the second quadrant. And in the second quadrant, sine is positive. So that's why we are getting a positive. Please, any questions before we go on?
Okay, sir.
Yes, I'm listening.
It means that if we have a negative number, we move anti-clockwise, ne?
No, we move clockwise. Clockwise is like this. Clockwise is like this. Have you seen that? You see, when you have a clock, have you seen that?
Yeah.
A clock moves like this. Can you see that? Can you
Yes.
see? So when it's negative, you move clockwise. When it's positive, you move anti-clockwise.
Also, our angle is subtended between 210 and 90.
Always you compare your angle with the x and not the y-axis, to the x.
Okay. Yeah, now I understand, sir.
Okay, good. Because the sign tells you the direction where the angle is going. Have you seen that? But wherever you get to, you always compare it with the what do you call it, the x-axis. Can you see that? Or you find the difference between that angle and the x-axis. Can we go on? Can we go on?
Yes,
Yes,
sir.
sir.
Okay, good. So our next one is cot. It is cot negative 5 pi. Cot negative 5 pi over 6. So here we are working in radians. Eh? So that means that everything must be in radians. 0 pi over 2 pi and 3 pi over 2 and 2 pi. So I'm fully aware that when you were in the high school, you were not really drilled so much on radians. You were most of the time working in degrees. So for the time being, if you are not so sure where this 5 pi over 6 will lead you, I will advise you just convert to what do you call it, degrees. Have you seen that? So that you at least you have an idea of where the angle is going to be. But remember that here is negative, so we are going to move in the in the clockwise direction, in this direction. So negative 5 pi over 6, if you are not mistaken, it will be negative 150 degrees. Have you seen? So here is 90, here is 180. So it is going to be somewhere here, if I'm not mistaken. Am I correct?
Yes, sir.
Okay, so 5 pi over 6 will be here. You see? So our nearest x-axis is pi. Have you seen that? So that means that your ref angle is going to be pi minus 5 pi over 6, which, if I'm correct, it will give me pi over 6. Have you seen that? So now that we're going to find cot. Have you seen that? Cot pi over 6 as our reference angle. Have you seen that? Now cot pi over 6 is the same as 1 over tan 1 over tan pi over 6. And this angle was in the third quadrant. In the third quadrant, tan is positive. Have you seen that? So we keep the positive. Then we know that tan pi over 6 is the same as tan 30. Tan pi over 6 is the same as if I can guess correctly, is going to be root 3 over 3 or 1 over root 3. The same thing. Root 3 over 3. So if we simplify, we are going to get 3 over root 3. Or some of you can write it this way. What do you call it? Tan pi over 6 is the same as 1 over root 3. So it will be 1 over root 3. Then the answer will be the same as root 3. It's the same thing. Please, any questions there?
Can you please repeat what you have just said?
Okay. You find out that when you draw your when we draw our special triangle like this, when we draw our special triangle like this, we have 1, 2, 2, root 3. So here will be pi over 6. Here will be pi over 6. Here will be pi over 3, 60 degrees. And here will be pi over 3. And here will be pi over 3. So we were finding cot. We saw that this thing was cot pi over 6. Cot pi. Our reference angle was cot pi over 6. So we know that cot will be the same as 1 over tan pi over 6. Now, tan pi over 6, when you are looking at it from here, it will be opposite over hypotenuse. So it's going to be 1 over root 3, which will be the same as root 3. Now, when you punch on the calculator, it's going to give you 1 over tan pi over 6 will give you root 3 over 3. And I'm saying that it's the same thing because this 1 over root 3 has simply been rationalized. They multiply the top and down by root 3 and root 3. Then you get root 3 over 3, which will give you, when you simplify it, will be 3 over root 3. So all that I'm saying is that 3 over root 3 and root 3 is the answer. Am I making myself clear? Am I making myself clear, please?
Yeah, it's a bit clear, say. I'm not quite sure, but it's a bit clear.
No, it's the same thing. You see, 1 over root 3. What I'm trying to say is that 1 over root 3 and root 3 over 3 is the same thing. That's all that I'm trying to say. Because when you rationalize, when you have 1 over root 3, rationalization, you did it somewhere along the line. You multiply top and down by root 3. Have you seen that? And root 3. You see? Now, root 3 times root 3 is 3. So you are going to get root 3 over 3. So all that I'm trying to say is that is the same thing, but you must be, because you are working with multiple choice, you must be able to know this. So that if they confuse you with the answer, you will know what to do. You understand me?
Yes, I understand.
Okay, good. Please, any questions again? So you see, you simply have to pick up the understanding. Once you can pick up the understanding, there is no question you cannot answer on reference angle. You understand me? The only thing that you have to do is to pick up the understanding. Okay, good. So let's go to the last one. The last one, we have sec 420. We have sec 420. Sec 420. Sec 420. Now, let's look at it this way. Now, we are working in degrees now. You see that? So we are going to go 0, 90, 180, 270, 360. So let's go on. Now you have to know that because we are in 420, that means that you see we are 360. Here can be 4 what do you call it? Here can be 450. Have you seen that? Here can be 450. Here can be 540 in that order. We can go on and on because that's why we say trigonometry trig is periodic. Is that clear? We go and to the same place in that order. So now let's look at where 420 is going to be. 0, 90, 180, 270, 360. So 420 is going to be here. Have you seen that? So we have 420. So please, because we have gone a full cycle, now your closest angle will not be 90, will not be 0. It will be how much? 360. Have you seen that? Because we have gone a full cycle and come back here again. Have you seen that? So your ref angle, your ref angle is going to be 420 minus 360, which will give us 60 degrees. Please, is there any questions up to point for how we got a reference angle? Or can we go on? Please, is there any questions on how we got our reference angle?
No questions, sir.
Okay, good. So in that, once we have found your reference angle, we know that we are going to look for sec 60. Now sec 60 will be the same as 1 over cos 60. And we are in the first quadrant. In the first quadrant, cos is positive. So we are going to have 1 over cos 60. It will be the same as 1 over 2. So it's going to give us the answer to be 2. Please, any questions, please?
No questions, sir.
No questions. Okay. Okay. In the absence of no questions, once you understand this, I should expect you able to answer any questions on reference angle, because it's not memorizing. It's simply trying to understand what you are doing. Memorizing will never help you. Memorizing will never help you. But try and understand what you are doing. Memorizing is not going to help. Am I making sense to you?
Making sense. Eh?
Okay, good. So, in the absence of no question, the next thing that tomorrow we are going to look at the sine rule and cosine rule, and we look at some of the questions on those complex angles. But the next thing that I would like to talk to you about is how to draw trigonometric graphs. Is how to draw trigonometric graphs. Now, again, here too, I know that back from the high school, most of you are used to degrees. But as I've said, radians is more acceptable compared to degrees. Is that clear? So you must acquaint yourselves on how to use degrees. Sorry, how to use radians. How to use radians. So in drawing our how do you call it? Our trigonometric functions, we are going to focus more on radians compared to degrees. Good. But there are some basic things that you must know. I don't know that you must first know on trigonometric graphs. There are some basic things that you must know on trigonometric graphs that I'm going to tell you. Now, the first thing that I will tell you is that it's not even on trigonometric graphs. On any graphs, at times, most of you concentrate on how your graph is going to be beautiful. Unfortunately, the beauty here is very useless. The beauty here is very useless. What is important here is your points. Your points. What do I mean by that? In an examination situation, if the marks is 6 marks, then you draw a beautiful graph and your points are wrong. Your points are wrong. The maximum mark you can get is 1 mark for the shape of the graph. The maximum you can get is 1. But if somebody plots correct points and does not even draw the graph, I can give the person full marks. Because the argument is that once you know where the points are, the graph is a mere formality. So it's not only it's not only in quadratic graphs. Sorry, in trigonometric graphs. In any graph, the most important thing is you getting the points correctly, not the graph itself. But the main focus is you getting the points correctly. So my focus here is going to be on how you should be able to get your points correct. Okay, good. Now, a quadratic graph have got some attributes that you must know. The first one is amplitude. 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 Now, amplitude has always got a, how do I call it? Amplitude simply tells you how far is your graph away from the x-axis. So, for instance, if I have y equals to, let us say, a sine x, my amplitude will always be the absolute value of a, which is a, or simply put, amplitude is always a positive. Amplitude is always a positive. So if I have y equals to negative sine x, the number in front of the x is -1, but amplitude can be -1. The amplitude will always be the modulus of -1, which is going to be what? Which is going to be 1. So amplitude is always, but that's the first thing that I would like you to know. That amplitude is always. Then, so for instance, if I have negative 2 sine x, that means that my graph is going to go like this. Let us say here will be 2, and here will be -2. So my graph will go here up to -2, come to 2, then come. So here is the amplitude. How far the graph is far away from the x-axis. That will be the amplitude. So now the first thing that you have to know, as I've said, is the amplitude. And as I've said, even though it is -2, amplitude is, when you are writing it, is always a positive number. Please, any questions about amplitude before we go on? Please, any questions about amplitude?
No questions, sir.
Okay, good. Then the next one is the period. The next thing you have to know is the period. Now, whenever you are drawing a graph, you must always at least draw one period. Whenever you go, when you come back to the same place, you must always be able to get a period. At least draw that with one period. Good. Now, sine x and cos x. Let's say sine ax and cos ax. The period is always 360 over the number in front of the x or the theta, which is a, over a. But when you have tan ax, the period is always 180 over A. So in effect, if I have sine 2x, my period is going to be 360 over 2, which will give me 180. So in that sense, if I'm drawing this graph, my period will be at 180. That means that when I go here and come back, I must return at 180. But if I have, let's say, sine x, my period, because the number in front of the x is 1, my period will be 360 over 1, which will give me 360. So if I draw my graph, I must, when I start from 0, I must come back here at 360. But as I told you initially, that we are going to work more in radians. We are going to work more in radians. So if I have, let us say, we are working in radians, then I have sine 2x. My period will be 2 pi over 2, which will give me pi. So that means that when I draw my graph, I must return at 2 pi. So I will go like this and come back to pi. So that means that when I have sine x, my period is going to be pi over 1. So, sorry, 2 pi over 1, sorry. So that means that my graph, one period must give me 2 pi, or will end at 2 pi. So we will go from 0, then we come back to 2 pi. So in the same way, if you have got a tan graph, for instance, tan x, the period is going to be equals to 180 over 1, which will give me 180. But if I'm working in radians, then it's going to be pi over 1, which will give me pi. You must know the distinction when you are working in radians or when you are working in degree. Please, any questions there?
No questions, sir.
Okay, good. Then the next thing that I would like to talk about is what we call the phase shift. So before I talk about the phase shift, let me talk about what we call the step. The step. Now, what do I mean by the step? What do I mean by the step? Now, when you have, let us say, sine x. Now, when I'm drawing a graph like this, the most important thing is for me to get these points correctly, these points here correctly, these points here correctly. So now the question is, if I draw this graph, let us say if I draw a graph like this, excuse me, good. If I have a graph like this, and here I'm using sine x. Now the confusion here is that what should be my interval? Should it be 30, 60, or should it be 45, 45, 90, or should it be 90, 180, in that order? Obviously, all of you cannot have different intervals. There should be a uniform interval so that you can get your points correctly. Have you seen that? Now, that is where the step comes in. So, your step is always the period divided by 4. So, divide by 4. Then this is for cos and sine graphs. But when you have a tan graph, your period is going to be your step is going to be equals to whatever your period is over 2. So your step, that is how you find your step. So for instance, if I ask you to plot sine 2, you have to know that your amplitude will obviously be +1. Your period is going to be equals to 180. Sorry, your period will be 360 over 2, which is going to be equals to 180. Or your period will be 2 pi over 2, which will be equals to pi. But you also need your step. Your step, which will be pi over 4. So when I'm drawing my graph, I know that my first point will be 0. My second point will be pi over 4. Pi over 4. My third point will be pi over 2. That will be my interval. My next point will be 3 pi over 2. And my last point will be pi. Then I get 1 period. So the step is very, very important. Please, questions with the step, please. Your question.
I'm concerned with step 1. This on sine 2x.
Yes.
Yeah, with the amplitude, you said is the distance from x and y. So in that first example, the amplitude was 2.
Yes.
Yeah, in our first example, you said that the amplitude will always be positive. Then it was minus 2 sine. Oh. Okay.
Yeah, it was minus 2
Sine
sine x.
x.
Yeah. Yes.
Also, so our amplitude is this minus 2. Ne?
Yes, but it's going to be positive. How do you see that?
Okay, that was all my question I
But
got.
here it was 1. So the number in front of the sign here was 1. Can we see that?
Yes.
Can we see that? Okay, please. I would like all of you to try this for me. Y equals to 3 over 2 sine minus pi over, okay, no, I'm having this. I would like all of you to try this for me. We have y equals to 2 sine I'm sorry. I'm having y equals to negative 3 over 2 sine half theta. Please, I would like all of you to tell me the amplitude, the period, and the step. A is for amplitude, P is for period, and S is for step. So all of you should do that, and one of you will tell me what the period is, what the amplitude is, and what the step is. All of us are doing that. Then I will ask for the answer from one of you. So all of us should try that now. I'm giving you 5 minutes, please. 5 minutes. Are we on course? Are we on course, please? Are we on course, please? Who can give me the answers, please? Answers, please. Hello?
Say,
Yes.
yeah, I was able to try finding the amplitude and the period, but in concern of step, yeah, I couldn't. Maybe someone will help. So with the amplitude, you said it's supposed to be positive.
Yes.
So it will be positive 3 over 2.
Okay, that
Then
one will
with
be
my
positive.
period, yeah,
Okay, period will
positive
be
3
how much?
over 2.
Yeah.
3 over 2, not 2 over 2. 3 over 2.
Okay, 3 over 2. Okay.
Then with period, you said that we divide 360 with a given number. So I divide 360 with 1 over 2 and give
Remember,
me
I got the
around
theta, yeah.
720
720, okay. Period is 720, is 360
over
over 2, which will be
1
how
over
much?
2.
720. Yeah. 720, yeah.
So with step 3, I couldn't follow.
Step will simply be the period, which will be 720, 720 over 4. You understand me? Whatever the
So
period is over 4.
why are we supposed to divide it by 4?
Okay. To help us when we are drawing the, what do you call it?
Mm.
Please, the step there, it is only to help us to draw the graph. But if you can see it, fine. You understand me? Because most of the time you miss that one. And once you miss it's only to help us to get the interval when you are drawing the graph. You understand me?
Say,
It's only to help us to know, okay, let's say if you are plotting a sine graph, okay, you start with 0. What will be your next point? Is it going to be 30? Or is it going to be 60? Or is it going to be there are so many points you can come up with. You understand me? So the step helps us to know which interval are we going to choose. Yes.
or say with the issue of dividing with 4 is to find intervals, ne?
Yes, exactly.
Or it means that in each graph we're going to draw, we'll have 4 intervals.
No, no.
Then
The
there might
step
be
only
more.
helps us to know what is going to be the interval in between your points. Okay, for instance, if I say this graph, exactly. If you are drawing the graph, what is going to be your intervals in between the points? How am I going to know that? You understand me? This graph that I'm doing is how do they call it? Sine half theta 3/2. Then we have this. What point are you going to put here? 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 Does that mean? So that helps you to know that. You understand me? Hello? Can you hear me?
Yes, sir. I managed to get the intervals, but I didn't use the step the way you showed, because if I use that the way you showed, I got first for 720 over 4 I got 180, and then 720 over 3 I got 2 240. Then for 720 over 2 I got 360. For 720 over 1 is obvious 720, but the difference, when you check the difference, is not equal.
I don't really get you. Why are you dividing by 4, 3, 2, and 1 at the same time?
I thought that's how we get the steps.
No, I said
Okay.
if it is sine or cos, you divide by 4. If it is tan, you divide by 2. Is that clear?
Okay, it's clear,
So
sir.
you see that here, yeah, rain.
So just finish explaining. Maybe you're going to answer the question I was about to answer. I was about to ask.
Okay, good. Okay, good. Okay, here. Our period, yeah. Our period was 360 over half. That gave us 720. So our step is going to be 720 over 4. That will give us 180. Have you seen? So now, what the step will help you to know is that the step will help you to know that on your graph, after 0, my first point will be 180. My next point will be 360. My next point will be 540. And my next point will be
Okay.
70. Have you seen? So the step helps
Yes,
you to
sir.
know that the interval that it must be between your points. That's all of the step.
Okay, so in other words, the step gives you a difference.
The difference between the various points. Good.
Okay.
Yeah, really.
I'm not sure if I fully understand, but what you just explained is that our intervals, the 180 is where the is like our intervals. It's what we're going to use for our intervals, right?
Yes, 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 yes,
Okay, thank you.
yes. It's very important because you see, if you don't get the intervals correctly, what happens is that you are going to, what do you call it? You are going to now be getting some strange decimals, and virtually you get a graph from. You understand me? So don't let us forget. As yes, Remy.
Okay, so sir, our amplitude is going to be 3/2, and our period is going to be, is it 720 or 180?
Period is 360 over half, so to be 720.
Okay, and then our first step is going to be 180.
Yes,
Our step is going to be 180.
yes.
Okay, thank you.
Mhm. Please, any questions again? Okay. Now, one last thing that we have to talk about is what we call the phase shift. The phase shift. Um, you know about shifts, phase shift, but um, for instance, if I have sine x, it will be the original. So if I have sine x minus 90, you know that sine x minus 90 means that the graph will go to the right by 90 units. So with the phase shift, you just pick x minus 90 and you equate to 0. So x is going to give us 90. Have you seen that? So once it's positive, that means that it's your phase shift will be 90 right. If it's negative, it will be 90 left. So for instance, if I have a graph like this, sine x plus 30, x plus 30 will be equal to 0, and x will be equals to minus 30. So the phase shift will be 30 left because of the negative. So it will be 30 left because of the negative. Please, any questions about the phase shift?
Questions, eh?
Okay, good. Now, on the other of no questions, let's get to a question on the graphs. Now, let's look at page um I just want to please let's look at activity 8,12. Activity 8,12. I think it is on page 30. 8,12. Okay. So the first question we have 3 sin x, y equals to 3 sin 3x. So can we all write down the amplitude, the period, the step, and the phase shift? Can we all do that? And somebody tell me the answer. That's the first thing.
Okay, so I think our amplitude is going to be 3. Period is going to be 120. Then step is going to be 30. Phase shift, we don't have any phase shift.
Okay, can you tell me these answers in radian? Well, I would like us to work in radians more. I want the answer in radians. I want the answer in radians. I'm waiting in radians. Yeah.
Sir,
Mm-hmm.
I think in radians it's going to be the same except for the period. Cause
Okay.
do we, but next to the x, do we put pi?
So what to be the amplitude? I just want the raw axis amplitude. We are working in radians now. What to be the amplitude? Wait, I'm waiting for you. What to be our amplitude when we're working in radians? Yes.
It's going to be 3, sir.
It's still going to be 3. You understand me? Nothing will change. Are you even raining? Are you even raining?
Sorry, sir, I got disconnected.
Okay, good.
Hello?
Okay, so raining.
Oh, can you hear me?
What will be the period now in radians?
Sir, can you hear me?
Yes, I can hear you. Raining. What will be the period?
Oh, okay. Um, the period is going to be 2 pi over 3.
2 pi over 3. Good. 2 pi over 3. And what will be the step?
Pi over 6.
It's going to be
1
pi,
over 6 pi, I think.
pi. Okay, 1 over 6 pi. Good. Then the phase shift. What will be the phase shift?
Nothing.
Okay, there will be no phase shift. Good. So you see where the step will help you. Okay,
Sir?
you see the yeah.
Yeah, can you please elaborate on phase shift? I don't know it anyway.
Yeah. Phase shift, you just equate this one to 0. Exactly. So you are going to have whatever is in front of the trig equals so 3x equal to 0. And x will be 0. So there will be no phase shift because x is equal to 0.
So when we are drawing a graph and we find that what is the purpose of this phase shift when drawing the graph?
The phase shift shows you how the graph is shifting from the original graph.
Oh,
You understand
okay.
me?
Yeah, I do.
It shows you at what level is the graph shifting from the original. Have you seen that? Okay, good.
Yes.
So um, let us make a table here. Let us make a table here. So we have a table of x, have you seen, and y. I will show you how powerful the step is. So we have this thing like this. Now, I know that I'm having a first point, which is 0. Have you seen? Now, the next my step is pi over 6. So my next interval will be pi over 6. Then 1 over 6 plus 1 over 6 will give me 2 pi over 3. You see? Then 2 pi over 3, 2 over 3 plus 1 over 6. If I can guess correctly, it's going to give me 5 pi over 6, if I'm correct. 2 pi over 3 plus 2 over 3 plus 1 over 6 will give us how much? Am I correct? Is it 5 pi over 6? Can somebody check for me?
So please just repeat what you are asking.
What is 2 over 3 plus 1 over 6?
5/6.
5 over 6. Okay, great, good. Then our next thing, we are going to 5 over 6 plus 5 over 6 will give us how much?
5/6 plus what?
Plus 1 over 6.
Isn't it gonna be 1? 5/6 plus 1. I think it's 1.
It's going to give us 1.
Let me see. Yes, it's 1. Because it's 5/6 plus 1/6. Yes, it's 1, sir.
It's 1. No, because it must give us up to the period. So there's something wrong somewhere. There's some. Oh, okay, the period. Okay, good. You see that we have pi over 6 and 2 pi over 3. So when we are drawing a graph, at least we must draw one period. You understand me? So we have 0, then we have pi over 6, then we have 2 pi. Now let's do it this way. Let's do it this way. A minute, please. We have this thing. Y equals to 3 sine 3x. 3 sine 3x. Then we know that our amplitude is 3. Our how do you call it? Our period is 2 pi over 3. Then our step is pi over 6. Then our phase shift is 0. So there is a very easy way to draw this on your calculator, but I just want to put it in a table form so that when I ask you to do it on the calculator, you can easily see it. So on the table form, you have your x and you have your y. So you find out that when I put 0 here, when I put 0 here, I'm going to have 3. Then I add the step. My next interval will be pi over 6, which is the step. My next interval will be pi over 6. Now, if I put pi over 6 here, I'm going to get 0. Then my next interval will be 2 pi over 3. Now, when I put 2 pi over 3 here, I'm going to get negative 3. So, on your calculator, you can easily get this point on the calculator. Now, on the calculator, you press mode. First of all, because we are working in radians, make sure that your calculator is in radians. Exactly. This is in radians. Then you press mode. Then you press table. Then you press table. Then you see f of x. So where you see f of x, you enter this function. 3 sine 3x. Then you press, you will see g of, some of you see g of x, ignore the g of x. Then after that, it asks you that where is your start? You start from 0. You start from 0. You end at the period, which is 2 pi over 3. And it will ask of your step. Your step is pi over 6. Your step will be pi over 6. Then you will see that it will give you this point that I have. Exactly. Can you try it? Let's see. Can all of you try it? Let's see.
You're correct, sir.
Good. So you see that so that now when you are drawing your graph, you know exactly where your points are. Have you seen? There's no way you can get your points wrong. So once you have been able to do this on your graph, you just go like this. You just go like this. On your graph, the graph becomes a mere formality. I know that I have 0 pi over 2 pi over 3. Then I know that my amplitude is 3 and minus 3. When it was 0, I have 0. When it was 0, it was how much? 3. Ne? 0 was 0 on the table. It was
Was 3.
y equals to
3
3
sine 3x.
sine 3x. I think 0 should be 0, if I'm not mistaken. Really, 0, 0.
Yeah, there's 0, 0. The first one is 0, 0.
Yeah. I'm very sorry. I think I made a mistake initially. You see, we have x and y. You see, so our points will go like this: 0, pi, pi over 6, and 2 pi over 3. Ne? So here the first one will be 0. Then I think we are going to go to 3. Then we are going to come back to 0, 3. Then we are going to come back to 0. Am I correct, Rainy?
Yes, you're correct, sir.
Good. So our graph will go like this: 0, 0. Then your next point here will be pi over 2 and 0. Your next point will be 2 pi over 3 and 0. So your graph is going to be like this for one period. So this is all that. The most important thing is this point, and this point. Have you seen that? So that is the importance of the step that we are using. Have you seen? Now, I would like to quickly go into one not so complex, but it's the same thing. You see, the beauty about this whole thing is your understanding. The moment you understand it, everything becomes so easy. So let's look at an example with let's go to activity A,13. I'm going to do question 2. Activity A,13 can be found on page 33. We are pressed for time, so I just want to one example you practice, then tomorrow we will see how it will go. We are going to do question 2. Now, question 2 says this. Y equals to 3. No. Let's do question 3. Sorry, question 3. A,1 question 3. It says y equals to 1/3 cos 1 1/3. Yeah, 1/3 cos 2x plus 6. Cos 2x plus 6. So if plus 60, sorry. If you are listening to me very carefully, it's so easy to draw this graph. Look, your amplitude is 1/3. It's going to be 1/3. Your period, now we're looking in degrees, né? So it will be 360 over 2, because there is 2 here, which will give us 180. Now your step is going to be 180 over 4, which will be 45. Then your phase shift will be 2x plus 60 equal to 0. So your x will be equals to minus 30. But please don't leave it minus 30. You must write that it is 30 degrees to the left. And this one will fetch you 2 marks. Have you seen? This one is 2 marks. This one is 2 marks. Period is 1 mark. Amplitude is 1 mark. There is no mark for phase shift, but so there's no mark for step. But the step helps you to know to get your graph correctly. Am I clear? Please, any questions from where we are going to?
No questions, sir.
Okay, good. So let us draw our table. We have x and y. Please, this time we are working in degrees, né? So make sure that your calculator is in degrees. Is that clear? So what do we have? The first one is 0. Then our interval is 45, 45, 45, our next interval is how much? 90. Our next interval is how much? um
135.
135. Then our next interval is how much? 180.
180.
So on your calculator, you just press mode, then you go to table. Have you seen? Then you go to table. Then where you see f of x, you are going to put cos the function, this function there. Is that clear? Then start. You start from 0. You end at 180. You end at 180. Then you have a step. No, please, I'm so sorry. Let's do this again, please. This is going to be our last question. Let's do this again. Um, we are having a minute. Uh, a minute. We have y. We have y equals to 1/3 into brackets cos. Is it 2? It was cos 2x plus 60. Cos 2x plus 60. Good. So what we are going to do here is that we know that our period is 1/3. Our sorry. Our amplitude is 1/3. Our period is 360/2, which is 180. Sorry for my writing. My step is 180 over 45. Then my phase shift is 2x plus 60. Which will give me plus 60 equals to 0. X equals minus 30. So it will be 30 degrees, 30 to the left. That means you're going to move to the left 30 degrees. Then on your this thing, on your calculator, have you seen? Calculator. You press mode table there. But wherever we see mode table, wherever you see f of x, please you don't put the phase shift, you put this one. X you put 1/2 Sorry, 1/3 cos x, cos 2x. Then start. You start from 0. You end at 180. Then your step will be 45. So your table will look like this: x and y. Then you have so your first point is going to be 0. Second point is going to be 45. Third point will be 90. Fourth point is going to be 135. And last point is going to be 180. Now, you find out that when you put it there, you are going to have on the table, the first point will be 1/3. Second point will be 0. Third point will be minus 1/3. Fourth point is going to be 0. And last point will be 1/3. Can you see that?
Yes.
Can you see that?
Yes, we can.
Good. So on your graph, you now have all your points there. On your graph, you have this. On your graph will be like this. On your graph, you are going to have this. I know that I'm going to have 45, 90, 135, 180. Then my amplitude is 1/3 and minus 1/3. So when it's 0, it's 1/3. When it's 45, it's 0. When it's 90, it's minus 1/3. When it's 135, it's 0. When it is 180, it is 1/3. Then you draw your graph like this. But please, let us remember that this is not our graph. Because our graph is supposed to shift 30 degrees to the left. So here you have 0 and 1/3. So your new point will be minus 30 and 1/3. Because the phase shift is 30 degrees to the left. Here is 45 and 0. 45 and 0. So your new point will be here. Will be 50 and 0. Phase shift 45 degrees and 30 degrees. And here is this point here is 90 and minus 1/3. So because of the phase shift, it will come somewhere here, 60 and minus 1/3. And these points are what is going to be marked. These are the points that are going to be marked. Then here is 135 and 0. 135 and 0. 30 degrees to the left, so it's going to be 105 and 0. 105 and 0. And this is the point that is going to be marked. Then here is 180 and 0. Sorry, 180, 1/3. But because it's to the left, it will come somewhere here. Then it's going to be 150, 150 and 1/3. So now your graph will look like this. 30 degrees shift to the right. Then we have the graph like this. And that depicts the 30 degrees shift that the graph moved to the left. Can we see that? Please, any questions? Please, any questions?
No
Yes,
questions, sir.
Innocent. No questions. Okay, please. It's already 2 o'clock now. So can you go and practice this? Tomorrow we are going to use the first 1 hour to look at more examples. So, as I said, the first thing, get your amplitude, get your period, get your step, get your phase shift. Then once you have that, you can easily put information on the calculator. So if you have, let's say, cos 2x plus 60, you only put cos 2x, don't put the 60 on the calculator. Then after you shift, if it is 30 degrees to the left, you just shift 30 to the left. If it's to the right, 40 to the right, you shift 40 to the right. It helps you to get all your points correctly. You understand me? So let's go and practice this. Tomorrow we are going to see how it goes and we will look at more examples. Is that clear? Is that clear?
Yes, sir, it's clear.
Okay, good. So please, let's close the class today because it's already past 2. And tomorrow we are going to look at, we're going to continue with this, looking at more examples. But as I've said, the key thing in the quadratic graph is to be able to get your points correctly. That is the key thing here. The graph is useless if the points are wrong. You understand me? And in my opinion, I think that's the best, this method is the best way that you can use to get all your points correctly. Exactly. So let's call it a day. Tomorrow, the same time, we are going to meet at 12 o'clock. Is that fine?
Bye, sir. Enjoy your evening. Thanks.
Okay, same to you. I'll see you tomorrow.